Hello and welcome back for Chapter 4, Lesson 3. We're dealing with angle relationships in triangles. So before we get started with this lesson, I want you to go ahead and work on this warm-up. Number 1, number 2, number 3. So here is my friend the pause dragon. Remind you to pause your device. When you get done, press play and we'll go over the warm-up together. All right, see you in a bit. Okay, let's see how you did. So this first problem says find the measure of the exterior angle DBA of triangle BCD if the measure of angle DBC equals 30, the measure of angle C is 70, and the measure of angle D is 180. So we're trying to find this angle. What you should notice is that this is a linear pair, which means that both of these angles add up to 180 degrees. So basically this angle plus this 30-degree angle equals 180. So let's just go ahead and write that. So I'm going to write it in symbols first. So the measure of angle DBC plus the measure of angle DBA is equal to 180 degrees because it's a linear pair. And then we're just going to substitute the measure of DBC, which is 30, right, in here. Substitution, property of equality. Then we just want to figure out what this angle is, so we're going to isolate this, get rid of the 30 using that subtraction property of equality to both sides, cancel, and we're left with the measure of angle DBA equals 150 degrees. So if you got that, awesome job. Make sure that your work looks like this. So if you don't have all of this, go ahead and rewrite, erase, and make sure that your work looks just like mine. Perfect. Okay, let's go on to number 2. Number 2 says, what is the complement of an angle with measure 17? So remember, complement, those are two angles that add up to 90 degrees, right? And the complement of an angle is 90 minus x. Do you guys remember that? I think that was from chapter 1. That's the complement. So if x is equal to 17, then we substitute that in. We get 90 minus 17, which is 73 degrees. That is the complement of 17 degrees. So these two angles are complementary, which means they add up to 90. All right. And on to number 3. Number 3 states, how many lines can be drawn through N parallel to MP? And there can only be one line drawn through N that is parallel. And I'm going to use those two lines. Those are parallel. Whoops, that wasn't the best symbol. Okay, to NP. Any other line we tried to draw, I mean, yeah, it's just one. There's one, just one. And if you remember, that was the parallel postulate. Just a little review. Perfect. Okay, on to our first theorem. Now, this is a super important theorem. It is called the triangle sum theorem. Triangle sum theorem, triangle sum theorem. I don't know, I just always have a fun time like saying that triangle sum theorem. Makes me happy to say. But this is a really, really crucial theorem. So basically what it says is the sum of the angle measures of a triangle is 180 degrees. So that means that the measure of angle A here, and the measure of angle B here, and the measure of angle C here, you add all of those up, measure of angle A plus measure of angle B plus measure of angle C equals 180. Boom, triangle sum theorem. Now, the reason why the triangle sum theorem exists is because what happens, do you see this little triangle here? Okay, so we have 1, 2, 3. Do you see that? There's like a triangle. And then we're kind of using that idea of the parallel postulate, and we're drawing a line that goes through B, line L, that is parallel to AC. So this line here is parallel to AC. Now if I extend AC a little bit longer, okay, and then I'm also going to extend this line right here a little bit, this side, what we have is we have two parallel lines and we have a transversal. So what we know by this, okay, so let's look, okay, what do we, so do you see that? Two lines transversal. These are parallel, right? And we have a transversal, okay? So what do we have? We have a triangle that there's three angles. 1, 2, 3. Okay, we know that all of these add up to 180 degrees because of the triangle sum theorem. Now, why? Why does the triangle sum theorem exist? Let's talk about it. So, if you look here, when we draw this auxiliary line because of the parallel postulate, right, there's only one line that can go through B that is parallel here. What happens is when there's that triangle, do you see how it like there's three angles, angle 4, angle 2, and angle 5. Now these are all a linear pair, which means all of these angles add up to 180 degrees, right? Angle 4, see how it's a straight line? So this straight line is made up of measure of angle 4 plus measure of angle 2 plus measure of angle 5, all equals 180 degrees. So what happens, we know that, so I'm going to write that. Measure of angle 4 plus measure of angle 2 plus measure of angle 5 equals 180 degrees because of the linear pair theorem, right? Those are all linear pair. But then what happens, and I'm not going to do a complete proof here, I just want you to see this. So we have two parallel lines and we have a transversal, right, that's cutting through those. And if you see by the alternate interior angles, we know that angle 1 is congruent to angle 4. So that means instead of writing angle 1, I can write a measure of angle 1, right? Those are the same. So I'm going to substitute that in. And then if you look over here on the other side, we have this parallel line and this parallel line. And then if we make this the transversal and we extend this here, do you see this? Make that transversal. We have these parallel lines here. What we have is 3 and 5 are two parallel lines, transversal. 3 and 5 become alternate interior angles. And that means that they're congruent whenever you have parallel lines, right? By the alternate interior angles postulate. So we know that 5 is actually the same thing as 3. So we can write, instead of measure of 5, we know 3 is the same thing. And boom, there we have it. That's how you get the triangle sum theorem, that all three of these angles equal 180. It's by drawing that auxiliary line, they're parallel, and then looking at those alternate interior angles. So that's not the formal proof. I mean, if we'd have to write a lot more for it to be an actual proof, but I just wanted to give you the idea of where this triangle sum theorem comes from. And we're going to be using it a lot, okay? So make sure that you make that a flashcard. It's super important. All right, let's go to our first example. So in our first example, we are looking at this picture here. It says, after an accident, the position of cars are measured by law enforcement to investigate the collision. So use a diagram drawn from the information collected to find the measure of angle X, Y, Z. So we're trying to find this angle right here. So what do you think? What do you guys think? What should we do? Do you see something? If you are saying, hey, use the triangle sum theorem because we have a triangle, we know two of the angles, but we don't know the third, you would be correct, okay? So let's go ahead and write that given information. What do we know? Well, I'm going to make that a 0. We know that the measure of angle YXZ is equal to 62 degrees. And we know the measure of angle x, z, y is equal to 40 degrees. Okay, and that's just given. So now we can do the triangle sum theorem. So I'm going to say that, let's start with this one. So the measure of x, y, z plus the measure of y, x, z plus the measure of, so we have the measure of x, y, z, we have the measure of y, x, z, and now we need this one, x, z, y. Equals 180 degrees by the triangle sum theorem. And I just love writing it like that, triangle sum theorem. Okay, then the next step is just substituting these values into the equation. Okay, so this is 62 plus this is 40. That is substitution. All right, now we just simplify, right? We need to add those two together. What is that, 102? And then we just need to isolate this to figure out what it is. So we're going to use that. Inverse operation for addition would be the subtraction property of equality. And cancel. We're left with the measure of angle x, y, z equals 78 degrees, and that would just be simplification. Simplify. There we have it. Perfect. Okay, on to the next one. So the next one says, use the diagram to find the measure of angle YWZ. YWZ would be this one. I'm going to change up my color. So now we're trying to determine this angle here. So let's see here. We have, what do we have? We have this triangle, we have this triangle, and then we have this big triangle. So I think that there's a couple different ways that you could figure this out. But what I'm going to do is I'm going to use this triangle. We know that this is 12 degrees, right? So that's given. And we know that this is 62, but we can figure this out, right? Because this is a linear pair. So how about, okay, we know this, let's use this to figure out this angle, and then we could do that triangle sum theorem, right? Because we know this angle and this angle, we just add them together, plus this one, it all equals 180. So that's how we're gonna solve this problem. So let's go for it. First, I'm gonna write down that given information. So 0 is going to be the measure of angle WYX is equal to 12 degrees. And this angle here, YXZ, is equal to 62 degrees. Make that 0, make this given. Perfect. Okay, so then we're just going to say these two angles right here, right, those added together is equal to 180 degrees. So we can say that the measure of angle WXY plus the measure of angle YXZ is equal to 180 degrees. Linear pair theorem. Okay, then we just do a little substitution. 62 goes here. And then what do we do next? Yeah, we just solve. We just need to isolate this. So I'm going to use that subtraction property of equality. Subtract 62 to both sides. And 180 minus 62 ends up being 118. 8, yeah. All right, that's simplify. Perfect. Now we know this is 118, right up here in this picture. So this is 118, this is 12. We don't know what this is, but we can use the triangle sum theorem to figure it out. And that's what we're going to do. So what do we have? We have the measure that we're trying to find, y, w, x. So, all right, can we see? Measure of angle y, w, x plus this 12-degree one, measure of w, y, x plus this 118 one, which is measure of angle w, x, y equals 180 because of the wonderful, magnificent triangle sum theorem. Then we just substitute in our values, right? So this is the one we're trying to find. Oh, did I write it wrong? Or did I write it right? Wait. Oh, you know, w, y, x and w, y, z. Okay, it's asking us to find w, y, z. So w, y, z. w, y, x and w, y, z are the same thing. So I'm going to change this w, y, x to w, y, z because that is what the problem is asking us to find. And I just accidentally wrote the wrong thing, but technically it is the same thing. So let's just keep with what the problem's asking us to do. Okay, so we're going to substitute in, right? So WYX, that's 12 degrees. We leave this, so 12 plus WXY, 118 equals 180. Okay, so substitution. What do we do? Just simplify and then solve, right? So you can do this. Go ahead and do it with me. So what is that? 2030 plus 130. Simplify. And then just isolate, right? So subtraction property of equality. And equals 50 degrees. And that's simplify. So there is our answer right there. Perfect, perfect. Okay, now it is your turn to check it out. So go ahead and use this diagram right here to figure out what the value of MJK is. Ooh, MJK, so this one right here. All right, where's my friend? Oh, here's my friend, the pause dragon. Make sure you pause your device, work it out. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. This should be fun. Okay. So, what do we have here? What do we have? So, as we're looking at this, I see that we have a triangle here. And we know this value. We're trying to determine this value. We know that these two are the same, right? But we don't have that value. So we kind of need to determine what this value is, right? So in order to determine this value, we kind of have to figure out this value. So what we're probably going to have to do is do a triangle sum theorem right here to figure out this value, and then those are the same, and then we will use triangle sum theorem for this value. Okay, so let's go ahead and get started. So, all right, cool. Okay, perfect. Let's go ahead. I'm going to go ahead and write down some given information first. So there's a lot of given information. So first, let's go ahead and we'll start here with JKM, this 104. So the measure of JKM is equal to 104. Then we can go this one right here, KMN. KMN is equal to 88 degrees. And then we have MNK, this one here. MNK is equal to 48 degrees. And that is all given. Perfect. Okay, let's start off with the triangle sum theorem. Okay, so that's going to be the measure of KMN, right? Plus the measure of MNK plus this angle, which is MKN. MKN equals 180 degrees by the triangle sum theorem. Okay, and let's substitute those values in. So we know that KMN is 88 plus MNK is 48 plus MKN, that's the one we're trying to figure out. Okay, so substitution. Then we just need to simplify here. What is that? 120. Let's see. 88 plus 48. 16, 12, 13. 136. Okay, simplify. And we just need to isolate this, so subtraction property of equality that's going to be 4, it's going to be a 7, so 44 degrees. Oh, wait, whoops, subtraction property of equality and simplify. Okay. So now we know that MKN is 44 degrees. We know that these two are the same, right? So we can say that JMK measure of JMK is equal to the measure of MKN because of, this is 6, because it's given, right? That's given information. And then by the, yeah, I think this would be the, if this is equal to this and this is equal to this, then we know that this is equal to that because of the transitive property of equality. So we can say that the measure of JMK is equal to 44 degrees because of the transitive property of equality. Do you guys remember that one? it's if A is equal to B and B is equal to C, then A is equal to C. Okay, so basically if this would be A is equal to B, and then B is equal to C, then we can say that, well, what would it be here? This is, okay, it would be, well, it's a little backwards here, but it's basically the same thing. So we're saying that if we were to call this our A and this is our B, right? If that was A and that's B, so A is equal to B and B is equal to C, then A is equal to C. So hopefully you guys see that. If this is A and that's B, A is equal to B, B is equal to C, A is equal to C. That's the transitive property of equality. Okay, perfect. So now we know that this right here, JMK, is 44 degrees. So now all we need to do is that triangle sum to determine this value right here, right? Triangle sum theorem. So let's do it. Changing the color. So what do we have? We have the measure of MJK plus the measure of angle JMK plus the measure of angle this one here, JKM, equals, and all of those three add up equal 180 degrees because of the triangle sum theorem, right? Then we just substitute in. So MJK, that's the one we're trying to figure out. JMK, that's 44. Plus JKM is 104 equals 180. So that's substitution. And then we just got to simplify. What's that? 148 equals 180. Simplify. And then just need to isolate, so subtraction property of equality. And finally, our answer, which is, that would be 2, that's 7, so 3, so 32 degrees. Simplify. So if you got that right, awesome, awesome, and I will see you in a little bit for the next example. If not, just go ahead and change your work so it looks just like mine. All right. See you in a bit.